So let's start part 8 of the series, and we are going to discuss initial value theorem first. So if Laplace transformation of function ft is fs, then limit of t tends to 0 of ft will convert into limit of s tends to infinite. Means initial value of t is 0, then s will go to infinite. And here you keep in mind s into fs. It's not only fs, it's fs into fs, s into fs. Okay, and this side you have t. Okay, so if here limit is t tends to 0, then here limit will be s tends to infinite. Now final value theorem. Okay, in this case, if t tends to infinite, then s tends to 0. I hope it's clear, right? Again, s into fs. See one question, and they have asked this question in GATE 2010 for 2 marks. Laplace inverse and this function 3s plus 1 s cube plus 4s square k minus 3s is given. If limit t tends to infinite ft is equal to 1, then the value of k is, they're asking the value of k is here. Solution. So as we know, just now we have seen limit t tends to 0 will be equal to limit s tends to infinite, then 0 here, sfs, right? Sfs. So now this sfs, fs is given here, correct? This entire thing is fs is given here, and you multiply s here, and already it is given, right? Limit t tends to infinite is equal to 1. It means limit t tends to infinite and limit s tends to 0, they both are equal, and they both will be equal to 1. So we'll solve for limit s tends to 0. Now this became a limit question, right? Now there is no more Laplace question, it is just a limit question now. So you cancel this s by this s after taking s common, and now substitute the limit s tends to 0. So this will be 0, this will be 0, this will be 0. So we are remaining with 1 by k minus 3 is equal to 1. So we got k value is equal to 4. I hope it's clear. Now it is really very important topic now. Seriously, it is very important topic. And in chapter number 5, in lecture part number 5 or 6, I told you that there we will not solve the Laplace transformation of differential equations. So here we are going to discuss that. So solving differential equation by using Laplace and inverse of Laplace. Let's see how. It is very easy, but first of all, like this kind of equation you will see. First you see the equation. Question is given d2y by dt square minus 2dy dt plus y is equal to 0, and initial value problems, initial boundary conditions are given. Y0 is equal to 1 and y dash 0 is also equal to 1. Okay, so we have to find out y at t is equal to 1. It means what? Differential equation is given and we have to find out solution, right? So there is one way to solve differential equation, what you know already, we understand in ODE chapter or PDE, but here we are going to solve this question with the help of Laplace transformation, and it is very easy and less time consuming. So first of all, keep in mind, wherever you have dy by dt means y dash, there you have to replace by s Laplace transformation of y minus f0. Okay, this 0 is initial boundary value condition. It will be given, okay, in the question. Just now I showed it was given. So now d2y by dt square, this is y double dash, and this you will replace by, you see here it was single dash, I mean single time differentiation, so I was using s. Okay, now it is 2 times, so use s square, and again same as it is Laplace transformation of y, and then this f0 is here, but because it was a 6 square, so one more s will be remaining here. Then you have to go for one more term, f dash 0, and keep in mind everything is negative. Okay, minus sign between every term. Then d2y by dtq, how will you write? Y triple dash, how will you write? Definitely s cube, and then Laplace transformation of y minus x cube, then s square, then s. Okay, and in this term no s. Here you start with ly, then you put f0, then f dash 0 and f double dash 0. Don't be confused with sorry, don't be confused with Ly and F0. Okay, you will you will be very clear when you will see this question. Okay, let's see this. So applying Laplace throughout the equation. Okay, so you see this much part is coming just by replacing d2y by dt square. Okay, so 2 times second derivative, so s2 s square ly and s y0 and y dash 0. Fine. Now this much part is coming because of this dy by dt, correct, as Laplace of y and y0, and here we are taking simply Laplace of y, and Laplace of 0 is 0, no doubt. Okay, now what is remaining? Just take common. Ly is here and Ly is here and Ly is here, so take Ly common, will be remaining with s square minus 2s plus 1. Then take y0 and y0 common, so I took y0 common, s minus 2 is there now. Then we are remaining with y dash 0. Okay, this is equal to 0 now, this is equal to 0. Okay, so now substitute the given values. Y0 is also 1 and y dash 0 is also 1, so you keep here y0 as 1, y dash 0 is 1, so we are remaining with this equation. Now solve this equation and find out Ly, Laplace of y. We are getting s minus 1 by s minus 1 whole square. Then again solve, then Ly we are getting as 1 by s minus 1, then send L that side. Okay guys, till here we applied Laplace. Okay, now just you send this L that side, it will be L inverse, means now we are applying, after this step we are applying inverse of Laplace. Okay, so it is 1 by s minus 1, so it is nothing but e power 1t. E power 1t simply I am writing for simplicity, this is going to be e power t. Fine. So they are asking y1, substitute 1 here, we got e as answer. Fine. See one more question they asked in 2006, 1 mark. Solution of differential equation x dot t plus 2xt is equal to delta t. This delta t is definitely impulse function, right? We have discussed in some video, some part, I don't know which part. If you're coming from the beginning, you will be knowing. Now with initial condition is given, it will be always given. Okay, and sometimes it will not be given, it will be some constant, like it will not be given with 0. Sometimes it can be given with pi by 2 is equal to 1 or something. That kind of question nowadays they are not in trending for GATE exam. Okay, so I did not make that. Solution. So taking Laplace, so you can see this much part is coming only from this one, and then you take Laplace of x, so I'm taking Laplace of x. This equation is given in terms of x, don't worry, the previous question was given in terms of y. So Laplace of impulse function. So in the first video, in some video we discussed Laplace of impulse function is 1, and then take Laplace of x common from here and here, so we are remaining with x plus s plus 2, not x, s plus 2. Okay, then you send this here, so we got Laplace of x as 1 by s plus 2, and then you send this L that side, so it became L inverse, means now it is saying us to find out inverse of Laplace. So this 1 by s plus 2 will convert into e power minus 2t. So x is equal to e power minus 2t is our answer. I hope it's clear. Okay, move to the next video. Thank you.